Hey, welcome back. So in our last video, we got started by writing some helper functions that are going to be really useful in the bulk of our algorithm down here. What I'm going to start by doing is removing all of our test cases that we wrote in our previous video. We no longer need those. Great. And I'm going to direct my attention into this permalone function right here. In here, we need a couple of things. First, we need an array to store all of our possible permutations for the string we pass in right here. So I'm just going to call this permutations. Make sure I spell that correctly. And below, we're going to write a nested function to help populate this permutations array. So we can just call this function. How about populate permutations? That sounds like a suiting name. From here, what I'm going to do is actually open up another new tab, and I'm going to go over to Google. From here, we're going to be looking at another resource that's going to help us make sense of the algorithm we're going to be writing. It's on a site called Geeksforgeeks, so I'm going to type in Geeksforgeeks, multiple permutations. Coming to this first link right here at geeksforgeeks.org. Now, right here, they're explaining what a permutation is, that we already know, but after that, they provide us with an extra piece of context that we weren't aware of before. A string of length n has n exclamation point permutations. So in math, if you see a number followed by the exclamation mark, that means something called a factorial. I'm going to open another new window right here. I'm going to go over to Google and I'm going to type in factorial, and we're going to go to a site called Math is Fun. Coming to this link right here, factorial function at mathisfun.com. And right here you see we have a little explanation. So 4 factorial is essentially 4 multiplied by every number that comes before it. 4 times 3 times 2 times 1, which results in 24. If we want a factorial of 7, we take the original number 7 and multiply it by everything that comes before it. So 7 times 6 times 5 times 4 times 3 times 2 times 1, and we get the output 5040. Now, keeping that explanation in mind, I'm going to close this window and come back over to Geeksforgeeks, and we're going to look at this string right here. So say we wanted to get all possible permutations for the string ABC. Well, we know that a string of length n, in this case n is 3 since we have 3 characters, 1, 2, 3, it will have n factorial permutations. So a factorial of 3 times 2 would give us 6 times 1 would still be 6. So we have 1, 2, 3, 4, 5, 6 possible permutations for the string ABC. Below, you might also notice a little diagram here. This is really what's going to help us make sense of our recursive function that we're going to be writing. So this might be maybe intimidating for some of you looking at this, but we're going to relax and walk through this one step at a time. So let's just look at some things we notice about this tree-like structure right here. We have the string A, B, C. And because we have 3 characters, you'll notice that this tree-like structure right here has 3 levels. We have 1, 2, 3 going across. And every possible permutation for the string ABC trickles down to the very bottom. So at the very bottom we have 1, 2, 3, 4, 5, 6. We have all 6 of our permutations down here on the last level of our tree-like structure. Another thing you might notice is that some letters are red and some letters are green. And for every level of our tree, we have one more red letter than we previously did. So we have no red letters here. we have 1 here, and on this level, for every permutation, we have 2 red letters. So what this means is essentially what we're doing, looking at the first character A, we're swapping A with every subsequent character in the string that comes after it. So right here, we're swapping A with itself. Over here, we're swapping A and B, so we get the string BAC. And finally, on this level, we're swapping A with C, so we get CBA. So I think that would be a really good place to start. Back over in FreeCodeCamp, what we can do is take the string, lock A in place, and swap it with itself, including every character that comes after it. So I'm going to leave this window open, and I'm going to come back over to FreeCodeCamp. Now, our Populate Permutations function is going to take a couple arguments. The first is a string, and the second is a start index. So start, you can call it start index, IDX. And I notice that right here, this variable string is already declared. So up here, I'm just going to call this string spelled out instead. So string. Now in here, we're going to be using a multiple pointers pattern, just like used in our helper function right here. I'm going to make 2 new variables. I'm going to call the first one pointer A, and we're going to set that equal to our start index, and another one, which we're also going to initialize to our start index, pointer B. And pointer B is what's going to be moving forward while pointer A is locked in place. So for example, if pointer A is 0, our start index is 0, we're going to look forward, moving forward pointer B, swapping A with itself and everything that comes after it. So below, I'm going to make a new while loop. And in here, we want to say loop while pointer B is less than string.length. And in here, what we want to do is get the swapped characters for our start index, pointer A, and wherever pointer B is inside of this loop. So we can say const swapped string, setting that equal to a call to get string with swap chars. And inside of here, what do we want to pass in? We want to pass in the string. We want to pass in pointer A, and we want to pass in pointer B. Perfect. Directly below, just for demonstration purposes, we can say permutations.push, passing in our swapped string. Swap string, and then to keep this loop going, pointer B plus plus. Pointer B plus plus. Great. Now, what we can do outside of our helper function is call it. We want to call Populate Permutations. And the string we're going to be passing in as our string, we're getting in our permalone function right here. We can pass in our string, and we want a start index of 0. After that, I'm going to go ahead and console.log permutations. All right. And just to verify that things are working, I'm going to use the exact same string that they were using in the Geeksforgeeks example. We're going to pass in ABC. Now, if everything is working as expected, the 3 strings here should match the 3 strings we have in the second level of our recursive tree on the other page. So I'm going to come back over here. We have ABC, that is correct, a match. We have BAC, that is indeed the second one, and the last one, CBA, that is also a match. Now in the next video, we are going to learn how to make recursive calls on each of these 3 permutations here to get all 6 possible permutations for our initial string at the very top. That is coming up. Stay tuned for the next video.